Welcome to this demonstration on how to deploy volumes on top of EC2. So the first thing you'll have to do is go to signup.volumez.com and register for an account. There's an approval process in place, so you'll have to wait to get you approved after. Subsequently, what you can do is go to our GitHub page at volumez/volumes, github.com/volumez/volumes, which has our Terraform scripts to deploy the environment. The requirements are Terraform, a shell, for example the Cloud Shell on AWS account, and Git installed. That's really it. So I already have a Cloud Shell running here. Let me make a directory called AWS demo, cd into that, and clone my Git repository there. Subsequently, I'll go back and go to this EC Starter folder for Amazon EC2 and VI the EC Starter file. So this file has the parameters of Terraform to deploy and use EC1 with volumes as a prefix for the names of the resources. You can use this to deploy into existing environment, and will deploy 2 media nodes of type I4I 2 extra large. Also, we'll deploy an M5N extra large machine as the application node, where we'll mount the volumes into. I'm happy with the defaults, and I'll just do Terraform init to initialize Terraform. And when that is done, I'll apply the var file. And then when that is done, it will prompt me for a token. So after you signed up on the Volumes portal, you can log into the Volumes portal, and under developer info you can find the JW2 access token for the tenant. This enables our Terraform scripts to actually connect the nodes to the Volumes environment. So we'll provide that, and then you will get a summary of Terraform, what it will do. I'll hit yes, and this will deploy the infrastructure into Amazon EC2. And there's not much more to it really. After this, we'll go to the Volumes portal and configure this environment further. With that, let's speed up because this will take a while. I'll see you shortly. And we're back. It's now done. The next step we'll have to do is take out the key of the SSH. We have that described here on the page as well. So I can do Terraform output of the SSH key. Let's call that AWS demo.txt. I always find it more easy to actually get the file out instead of all this copy pasting. AWS demo.txt, download. And let me actually jump into this. These are all the files. Open the AWS demo.txt. Keep that handy, and then using puttygen, I'll load the file AWS demo.txt and save the private key AWS demo.ppk so that I can putty into my Bastion host. So let me show you the environment that has just been deployed. I always have to look which one it probably is. MK8Z. These are the instances we asked to deploy, and here's the public DNS name for the Bastion host. So let me put that here. I think I already have the key set to yes. The connection is good, so let me save that as well, open it up, and the username is EC2-user. So now in order to sign into my app node, I'll also need the key. And let me paste that here. chmod 400 aws demo.key ssh -i demo EC2 user at the app node. And the app node is this one. And the private IP is 209. Yes. So now I'm signed into the application node. Okay, we'll use that later. For now, what I want to do is go back to the Volumez portal and see whether I see the nodes. So indeed, here on top, we see 3 new nodes. The other ones are another environment. So these are exactly the nodes that I see in Amazon. B8, A9, 3D, B8, 3D, and A9. I already forgot them. But let's go back. B8, A9, 3D. Yes. These 3 instances are now registered in Volumez. So Volumez has visibility thanks to the connector. The connector was installed through the Terraform, but you can also install it manually using these instructions here. In the media, I'll also see new free EC2 based drives, assignment free. So these are the drives that are attached to the 2 extra large, 1.7 gigabyte, 1.7 terabyte drives. Let me hit assign because this takes a while and then I'll explain what this is doing. So by hitting assign, we will profile the drives. So they're now in assigning mode, and after that will be in assigned mode. So we're profiling the drive. We're really testing what are the capabilities of this drive. So let me show you a previous created environment here. Like here, those nodes are offline, but here you see, let me go on top. Here you'll see the latency envelope of the drives, the free size, the free IOPS, and the free bandwidth. And these machines are used, so the bandwidth is, or the capacity is not high. For the ones that we're currently assigning, we don't see anything yet, but we'll get back to that once it's done. What we now can do is create a policy. So let me show you how to create a new policy. So here's the new policy. I can give it a name. And I first have to define my capacity requirements. In terms of capacity, we have 2 modes: capacity optimized, performance optimized. It kind of says it. Capacity optimized, we apply erasure coding, compression, dedupe, and things like that to save on capacity. Performance optimized, we don't do that because capacity optimization obviously has CPU overhead. In performance optimized, we don't do any of that. The next setting, I'll do performance optimized. The next setting is how much space do we allocate up front. If I want a terabyte and I put it on 20%, it will allocate 200 gigabyte. Again, this is for pooling purposes, for example, but let's set that to 100. And I have to set my media failures. As you can recall, we have 2 media instances on 2 nodes. So my max resilience is basically RAID 1, 2 copies on the same. So I can sustain 1 media failure, 1 zone node failure. I cannot sustain zone failures because we didn't deploy in zones. By the way, that is possible, of course, in the Terraform as well. In terms of read and write bandwidth, let me say I need 500 MB per second of write and 1000 read. I happen to know the capabilities of these drives that we selected. And let's say I need 40,000 write IOPS and about 80,000 read. Or not, let me say 100,000. 100,000. The latency I always leave at 500. You could lower it down, but the capabilities are there. We have this avoid reads across zones. That doesn't apply here in our setting right now. but you can imagine what it does, right? It avoids reading from an application node to a media node that's in a different zone. And we have capabilities to do encryption at rest with keys that are provided by Volumez. If I hit submit, the profile's created, and I now will be able to create a volume. For that, let's first check what I have done, what I have here in my media, because it should be done by now. Let's see the state online. And let's go back here. These are the machines, A9, 3D, now I do recall. And they are assigned, and I should now be able to actually show you the telemetry that we got out of this. So after profiling, which really is a patent-based profile, where we really verify how much can these drives, the physical drives, do. And we found that in terms of read and write latency, we are at 100 to and 25 in write. And actually the second one is probably a bit further away from our environment, so it's a bit higher. It also says we have free IOPS read and write of 130K for each machine and 110K for write, as well as 1200 read, so we should be able to do the 1000, as well as 1000 in write. And we always, so we always lower it a little bit in order to make sure that we get the performance. So with this, I should be able to create a volume called AWS demo, where I assign that new AWS demo policy, and it's 1.7 terabyte drive. So let's do a terabyte in US East 1A. Now our policy engine will check if you have media in place that can handle this capacity, and it will then take that capacity to create the volume. It doesn't give errors, so it's actually able to provide this. So here's the summary. It provides the input that we provided in the policy on resilience and performance. And here it also shows that it will do rate 1 and that it will use these two media in the 3D and the A9 machines. If I now create the volume will be created and configured for us through the connector, the VLC connector that we have running on the instance types. So now the volume is available, and now I can attach that volume to my instance, my app node instance. So let me pick AWS demo. Let's take the top snapshot. We also support snapshotting, instance snapshotting, as I've said before. But currently I don't have snapshots, so I'll have to take this. And what it will show here is the B8 instance, which, as you may recall, is our app node here. I can also show the media nodes, so technically I could also attach them to media nodes, but obviously resilience-wise, that's probably not what you want. And I can give it a mount point, so mount/volumes of /FIO. If I go and submit, it will mount that volume into our app node, in which I actually have my session. So I can go to cd/mount/volumes/FIO. ls. There's nothing there, but I have the mount point ready here. And here I did a df. You see the 1000 gigabyte, the roughly terabyte that we have allocated in this space, which will provide the capacity that we have provided earlier. So I switched to full screen mode to show you an FIO test on the environment that we created. For that, I'll go into sudo first because I don't want to mess with the permissions on the mount points, and actually run an FIO. So here's the same directory, right? The mount/volumes/FIO. I'll run lib io direct1 with an I/O depth of 32. This is fairly arbitrary, I must say. 16 jobs because I have a 16-core machine, and 4K random read option on 1 gig files with 100,000 IOPS. Again, fairly arbitrary. I already have the files laid out, so if I hit the test, it will run the job. And here you can see I can reach that 100,000 IOPS that I defined in my policy. I don't even fully exhaust the bandwidth. Again, it are small blocks. It's beyond the scope of this demonstration to show you all of the optimization in FIO. But please feel free to contact me or us to walk through your use case and demonstrate it in the context of your workload and your needs. So let's also see what the Volumez portal will do with this. So we're back here in the Volumez portal. You see some data going here. Actually, these are the 100K IOPS that we have generated in the FIO. But let me show you our monitoring capabilities at a high level. You can go to Monitor, Volume, and I can select the AWS demo volume. And this shows the details about this environment, right? I have the 1 terabyte, 98% is left. And I see some further details around physical provision capacity. I also see the read bandwidth, the read IOPS. Here we've seen 100K IOPS going through our FIO. We see that it was 4 KB, and we see the latency envelope here as well. Again, there's so much to this. You can optimize this further. Feel free to contact us to show you what we can do. Again, we can hit 2 million IOPS, 15 gigabyte per second at very low latency, but it all depends on the workload, the block size, and the environment. I hope this gave you some insight into an initial setup of getting Volumez up and running, and I look forward to the next videos and the next webinars that we'll make. See you soon.